Greetings, everyone. I'm Jeremy Fischer. I'm the manager of Jetstream Cloud. We are a National Science Foundation funded project. We've been in two parts. So the first part was Jetstream 1. That one is still underway, though, in the process of winding down. We were funded in 2015, and we were funded on a five-year grant, and then we were extended. We were awarded Jetstream 2 last year and have been in the process of building it out. We started early operations on Jetstream 2 recently, so we're soon to start the process of getting folks from Jetstream 1 to Jetstream 2 and extending what we've been doing. So a little bit about what we've been doing. So a little bit about what worked with Jetstream 1. So virtual machine environments where people got full root privileges. They could run as long as they want, as long as they had an allocation. And those allocations were via Exceed, which is another NSF funded project, and were free. You basically just had to write a request to get access. So we've literally had allocations that have been running since we came online in 2016 that are still running today, and that we expect to transition over to Jetstream 2 as we move forward. Another thing that worked was the development of trial allocations. So basically anybody can come and get a very small number of core hours, about 1,000 core hours, to try things out and see if it'll work for their research or for their educational purposes. Some of the things we found didn't work, and that was forcing smaller allocations into the research allocation process. If you're not familiar with Exceed, the allocations process for research is basically what I like to call NSF Lite. So it's a 5 to 10 page allocation request. And for folks that are doing a very, very small number of hours, basically they need 50,000 or 100,000 core hours a year. Forcing them into that process was a little overkill, and it was difficult for them because a lot of times they were first-time researchers or early career researchers and maybe not used to going through that process. Lack of multi-year allocations hurt a lot of folks that were doing things like science gateways, where they had multi-year grants and basically wanted to know that they were going to be able to run, for multiple years at a time until their funding ran out. And then the other part was a lack of shared data set storage. So one of the things that happened with our funding was originally it was supposed to be one grant. It was split into two. And one of the things that suffered, unfortunately, was storage. So that's something that hopefully we've alleviated on this time around. So some of the things we learned, obviously storage, as I just mentioned. So we're going from basically having a petabyte at 2 clouds to having 17 petabytes across 4 clouds. 14 of that is on the main cloud at Indiana, which I'll show you in a moment. We're including GPUs this time around. We had a very, very small number for the last year or so on the Jetstream project for testing, basically to prepare us for the Jetstream 2 proposal. Bringing things together. So on Jetstream 1, we had kind of 2 different environments. We had a GUI environment that about 90% of our users used. And then we had the API side, which about 10% of the users used, though that made up about 50% of the resource usage. So those 2 domains were kept very separate. You couldn't manage resources across them, and that made for some difficulties. So on Jetstream 2, we've made one namespace, and you can interact with any resources from any of the various interfaces. Basically, trying to speed up our networks. So we've gone with Cumulus networks this time and Mellanox hardware to create better between node, between storage system, between control plane communication, as well as increasing the pipe out to the rest of the world. A big part is also just trying to have an easy way to integrate with the rest of the Exceed environment and also to meet our NSF requirements. So it's kind of looking at different ways that we can make the access better from Exceed and soon to come from Access as well, which will be the follow-on for Exceed. So a quick look at what Jetstream 2 looks like. So the primary cloud is at Indiana University, as I mentioned, 400-ish nodes there, and then 90 accelerator nodes with 4 GPUs each. Then we have 4 regional clouds that are smaller, and those are going to be around the country. So Hawaii, Arizona, TAC in Texas, and Cornell in New York. And so those will be smaller clouds that basically allow for using all of Jetstream 2's resources, using the central store of applications, but also giving a local resource and also giving a model for adding smaller clouds, local clouds onto the Jetstream configuration. We already actually have at least one potential candidate for adding another regional cloud into the network, and we hope to bring more than that in over the next 5 to 10 years. A high-level look at the Jetstream 2 architecture. So we have multiple interfaces in, as I mentioned. The Cacao interface from Cyverse will certainly be one. The Horizon is the OpenStack native GUI, and there's also the OpenStack command line and SDK. There's an interface called Exosphere, which started as a third-party interface that is going to be one of our primary user interfaces on Jetstream 2. And then the language bindings, as mentioned, the SDK having, excuse me, having container orchestration and things like that is a means of service running natively on Jetstream. OpenStack Magnum allows for container orchestration natively and gives a means into the system as well. So some of the differences between Jetstream 1 and 2, we grew a little bit. So we went from having 24 physical cores on a node to having 128 physical cores on a node. Our memory footprint has gone from 120 gig a node to 512 gig a node. We're also adding some large memory nodes. And as I noted before, there are 90 nodes with A100s, four GPUs per node, so 360 total for the primary cloud. So the capabilities, as we mentioned, so improved orchestration support. So that's bringing, whether it's Kubernetes or the orchestration of your choice, bringing it to the forefront, making it so it's easy to launch and manage on Jetstream. Elastic virtual clusters are getting a push button treatment. So if you come in through Exosphere, you can literally press a button and get a small Slurm cluster of your own. Federated Jupyter hubs are presently being developed, and so by the time we go into production, we hope to make it easy for folks to deploy their Jupyter hubs and then use a shared authentication system that'll be through OAuth and typically be through Globus Auth, I believe is what they're using to maintain institutional credentials and such for accessing Jupyter hubs. And then ease of sharing data. One of the problems we had with Jetstream 1 was that it wasn't easy to share research data between multiple virtual machines unless you were a sysadmin or knew something about setting up network file systems and such to share it. We're using a native OpenStack feature this time around that will allow, basically it's still NFS, but it's being managed by the OpenStack side. So you set up a share and then you just tell it to mount, and that's all you have to do. So we're trying to make life a little bit easier for the researchers. We have a commitment to 99% uptime. We do not take downtimes. So basically we do our maintenance on as a rolling thing. So nodes will get evacuated without the users knowing. It's worked very well over the last 5 years with Jetstream. We'll do our updates and then backfill and do the next node. Hybrid cloud support. So part of our mission is to not only provide cloud services to the national Cyberinfrastructure, but is to also work with CloudBank, to work with the commercial clouds and find ways of making it easy for folks to work back and forth between the commercial cloud or between their own private clouds at their institutions and Jetstream as well. Changing the user interfaces was a big key. Making things faster, trying to make things a little more capable, always trying to make things easier for folks to use. Because what it comes down to is most of our researchers basically want to come in and press a button and have their environment ready to use. And so that's our goal, is to do that in a very short order. Some stats on the side that have been on some previous slides, but lots of cores, lots of GPUs, lots of storage, and fast network is kind of where we've evolved to.
Jeremy, one more minute.
Sure. Some setup defaults. I mentioned that we are allocated via Exceed. So you come in and you get an allocation. You can get a startup allocation, which is fairly easy. Basically, it involves you give us a paragraph of what you intend to do, and then you can get up to 200,000 core hours on the CPUs, 400,000 core hours on large memory, and 600,000 on GPU. Now, there's some multipliers in effect with the large memory and GPU, but essentially you can basically get hundreds of thousands of core hours for about 10 minutes of your time. You can also get up to a terabyte of storage. Typically with the startup, we do have a little wiggle room there. To get larger amounts of storage, you do have to provide some more justification to us. I do have a link in here that has a little bit about the resources there. It has this information as well. When you move to the research side, there are no set limits. So you can have millions and millions of core hours available to you. You can have, I won't say hundreds of terabytes, but you can have tens of 20s, 40s of terabytes pretty easily without any issue. Just a quick look at some of our instance sizes. So as I mentioned, we run up to 128 cores and 512 gig of memory. So we range from a single core up to 128. If you've used a commercial cloud, this is going to look a little bit familiar to you. For GPUs, we actually do some slicing and dicing. So ganging GPUs is not available to us yet on OpenStack. However, we do split the GPUs. So we are looking at a prime use case for education, for splitting them, and also for folks that can basically fill a pipeline for one GPU. So timeline, so as mentioned, we are now in our 5th year of operations on Jetstream 1. We expect to see it sunset. Basically, we're going to stop allowing new allocations in the next month, and we're going to start sunsetting users at the end of this semester. So as the courses finish up, it'll start being the last of the users on Jetstream 1. We're going to open up Jetstream 2 to general usage, hopefully in the next couple of weeks. We're in early operations now. Things are by invite only. So we're bringing in some researchers and some of the users that have been experienced on Jetstream. We plan, like I said, to be in production in March and hopefully have a nice 5 to 10 year run past that. Our acknowledgement screen. So those are our grants with the National Science Foundation and what I like to call our NASCAR screen with our Jetstream partners. And that's it. Thank you all very much.